This is the only video that you need to watch on half wave rectifiers. So if that's something that you're interested in, welcome to this video. In this video I'm going to teach you how to actually draw a half wave rectifier in LTSpice and how to simulate it, as well as show you some calculations on half wave rectifiers, how to do those calculations so that you can pass your exams and become a computer engineer. Wave rectifiers are only possible because of this guy, a diode. Diodes allow current to flow in one way but not through the other. For example, current can now flow this way through the diode, but it can't flow this way through the diode. Let's build a simple half-wave rectifier to actually show you what I mean. I'm going to press V on my keyboard for a voltage, I'm going to press R on my keyboard for a resistor, and then I'm going to press F3 that can allow me to use wires to actually connect all of these components. It's always important to remember that you need to add a ground, so by pressing G on my keyboard I can add ground to my circuit. Now let's first start by making sure that this voltage is actually AC and not a DC source. So let's go to advanced, choose a sine wave, press a voltage of 10 amplitude and then a frequency of 1 kilohertz. And then for my resistor I'm just going to simply make it 1 kilo ohm resistance. So now we can simulate this. We can use a stoppage time of 5 milliseconds. And now as you can see, when I simulate over the voltage source, you can see this nice AC signal that has an amplitude of 10 volts and a frequency of 1000 hertz. And then if I go past the diode and simulate the voltage over this resistor, you can see that half of the waveform is actually cut off. That is why it's called a half wave rectifier. If I want to turn around the diode, you can see that the exact opposite is going to happen. Okay, so I've just turned around my diode and now simulating the AC voltage once again and the voltage over the resistor. You can see that the other half of the waveform is now cut off. So this diode in a nutshell actually turns this entire circuit into a DC circuit, because it only allows voltage to go from one direction. Although this is not a perfect DC circuit, because we still have this variation in voltage. If you want to make it a perfect DC circuit, then you're going to need a full wave rectifier, which we'll cover in the next video. Easy example of where you can use a half wave rectifier is by charging a battery. So let's say in this example V2 is the battery and this is my source that I want to charge the battery with. You can say a wall socket, for example. Now obviously I don't want the charge from the battery to actually escape the battery and go back into the wall, so that's why I'm going to use a diode to prevent the current from going this way. So let's do some calculations on this. Firstly, let's say that my source is 24 sine, so that means it has a peak voltage of 24 volts. Then my battery, which is VB, has a voltage of 12. I have a 100 ohm resistor, and then obviously the voltage over the diode. So most diodes vary, but they are between 0.6 and 0.7 volts. So let's calculate the peak diode current. So that's the maximum amount of current that's going to go through this diode. This is a simple calculation of taking the source voltage and minusing the voltage from the battery and the voltage of the diode, which gives you 114 milliamps. Now if we go to the circuit that I drew in LTSpice, as you can see here, if I simulate the current over the diode, you can see it is roundabout at 114 milliamps, so that is correct. So secondly, what's most important when considering diode circuits especially is calculating the max reverse diode voltage. So this is basically how much reverse bias voltage this diode is going to experience in the circuit. Now all diodes are different, but all diodes have a maximum amount of reverse voltage that they can handle without breaking down. So that's going to differ from different brands of diodes. So you're going to have to look at the spec sheet of the specific diode to see what is its maximum reverse bias voltage. And if we calculate it for this circuit specifically, you can see that its max reverse bias diode voltage is 36 volts. So if this diode can, for example, only handle 24 volts of reverse bias voltage, then you know that this circuit is going to break this diode. Thank you so much for watching this video on Half Wave Rectifiers. Stay tuned for the next episode, which will focus on full wave rectifiers. If you liked the video, please give it a like and please consider subscribing